Welcome to Learning How to Learn, Mastering the Art of Efficient Learning. In this course, you'll discover proven strategies and techniques to improve your learning efficiency, boost your memory, and overcome procrastination. Whether you're a student, a professional, or someone who loves personal development, these skills will help you achieve your goals more effectively. This is part 1, or lesson 1. Understanding the learning process. To become an effective learner, it's crucial to understand how your brain processes and retains information. In this lesson, we'll explore the fascinating mechanisms of encoding, storage, and retrieval. We'll also discuss the importance of active learning and debunk some common myths about learning that may be holding you back. Let's dive in. To understand how we learn, we first need to understand the basic functions of our brain related to memory and learning. Our brain processes information through 3 main stages: encoding, storage, and retrieval. Each of these stages plays a critical role in how we acquire and use new knowledge. Encoding is the first step in creating a new memory. It involves transforming sensory input into a form that can be stored in the brain. Think of encoding as the process of taking notes during a lecture. Just as you translate spoken words into written notes, your brain converts sensory information into neural codes. When you encounter new information, sensory neurons are activated. These neurons transmit signals to various parts of the brain, particularly hippocampus, which is crucial for forming new memories. The hippocampus then processes these signals and decides what information to keep and what to discard. This process is influenced by several factors, such as attention, emotional state, and the context in which the information is presented. For example, if you're studying in a noisy environment, your brain may find it harder to encode information effectively. Similarly, if you're stressed or tired, your encoding process might be less efficient. Once information is encoded, it needs to be stored. Storage refers to maintaining information over time. Our brain stores memories in different ways, depending on the type of information and its importance. There are 3 main types of memory storage: sensory memory, short-term memory, and long-term memory. Sensory memory. This is the shortest type of memory storage, lasting only a fraction of a second. It acts as a buffer for stimuli received through the senses. Short-term memory, also known as working memory. Short-term memory holds information for a brief period, typically around 20 to 30 seconds. It's used for tasks such as remembering a phone number long enough to dial it. Long-term memory. This is where information is stored more permanently. It can last from days to decades and includes everything from facts and knowledge to experiences and skills. The process of transferring information from short-term to long-term memory is called consolidation. This often happens during sleep, which is why a good night's rest is essential for effective learning. Retrieval is the process of accessing stored information when you need it. This is like opening a file from your computer's hard drive. Retrieval can be triggered by cues or context that remind you of the stored information. Effective retrieval depends on how well the information was encoded and stored. This is why active learning strategies, which we'll discuss shortly, are so important. They help strengthen the neural pathways associated with the information, making it easier to retrieve later. For example, when you repeatedly practice a skill or recall information, you reinforce the connections between neurons, making the retrieval process more efficient. This is known as the use it or lose it principle in neuroscience. Now that we understand the basic processes of how the brain works, let's talk about active learning. Active learning is an approach that engages students in the learning process more directly than traditional passive methods, such as listening to lectures or reading textbooks. Here's why active learning is so crucial. Active learning requires you to engage with the material, participate in the process, and take an active role in your own learning. This can include activities like discussions, practice problems, teaching others, and applying knowledge in practical ways. When you actively engage with the material, you create stronger neural connections, which improves both encoding and retrieval. For example, actively using the language through speaking and writing exercises is far more effective than just reading vocabulary lists if you're learning a new language. This hands on approach helps solidify your understanding and makes it easier to recall the information later. Active learning also promotes critical thinking and problem solving skills. Instead of passively absorbing information, you analyze, evaluate, and synthesize it. This deeper level of cognitive engagement helps you understand the material more thoroughly and apply it in different contexts. For instance, in a science class, conducting experiments and analyzing data encourages you to think critically about the concepts you're learning. This not only helps you grasp the material better, but also prepares you to apply your knowledge in real world situations. Despite what we know about the brain and learning, there are several persistent myths that can hinder your learning process. Let's debunk some of these common misconceptions. One of the most prevalent myths is that multitasking helps you learn more efficiently. In reality, the human brain is not designed to handle multiple tasks simultaneously. When you try to multitask, your attention is divided, making it harder to encode information effectively. Studies have shown that multitasking reduces productivity and increases errors. Instead of multitasking, focus on single tasking. Concentrate on one task at a time, give it your full attention, and then move on to the next task. This approach is much more effective for learning and retaining information. Another common myth is that intelligence is fixed and cannot be changed. This belief can be very limiting. In contrast, research in psychology has shown that intelligence is malleable. With effort, effective strategies, and a growth mindset, you can improve your cognitive abilities. A growth mindset is the belief that abilities can be developed through dedication and hard work. Embracing this mindset encourages you to take on challenges, persevere through difficulties, and learn from feedback, all of which are essential for effective learning. Many people believe that the more hours you spend studying, the more you'll learn. While time on task is important, the quality of your study sessions is what truly matters. Spending long hours passively reading or highlighting text is far less effective than shorter, focused sessions of active learning. Using techniques like spaced repetition, active recall, and varied practice can significantly enhance your learning efficiency. These methods involve reviewing material at intervals, actively testing your knowledge, and practicing in different contexts, which helps strengthen memory and understanding. Understanding the learning process is the first step towards becoming an efficient learner. By recognizing how your brain encodes, stores, and retrieves information, you can adopt strategies that enhance these processes. embrace active learning, debunk common myths, and apply the techniques we've discussed to improve your learning outcomes. In the next lesson, we'll delve deeper into specific memory techniques that can help you retain information more effectively. Remember, the journey to mastering the art of learning starts with understanding how your brain works. Thank you for joining me in this lesson, and I look forward to seeing you in the next one. Bye bye.